Hello friends. Another important aspect of quadratic equations is the graph of quadratic equations. My name is Yogeshwar Singh, and in this video I'll be explaining you the graph of quadratic function, relative positioning of the axes with respect to the graph of quadratic function, maximum and minimum values of quadratic functions, and meaning of various points on the graph of quadratic function. So let's start with first meaning of graphs. What do you understand by graphs? If I say a function y or fx is defined as 3 times x plus 1, here there are two variables involved. One is x and the another is y. Y is called the value of the function and 3x plus 1 is the function. X is the independent variable. Here x is called independent variable because it can take any values from minus infinity to plus infinity on its own. It does not require any other function to decide its value. But y is dependent variable because it can take values according to the values of x. Very simple. X you can put anything of your choice. Y will be the result of choice for x. You put the value of x is equal to 0, you get y is equal to 1. You put the value of x is equal to 1, you get y is equal to 4. So now let's see what is the graph of this function. The graph of this function is you put certain values of x and get the corresponding values of y, and then you plot these values on the graph paper and join these lines freehand, join these points freehand, and whatever curve you get is called the graph of that function. Here this is a linear function, so we are getting a straight line. Here if you put x is equal to 0, y is equal to 1, this point is 0 comma 1. If you put x is equal to 2, you get y is equal to 7, so this point is 2 comma 7. If you put x is equal to minus 1, you get y is equal to minus 2, so this is minus 1 minus 2. So according to the values of x, y attains its values. Any point lying on this curve from minus infinity to plus infinity is a point which satisfies this equation. That is, you take a point on this line, get the x coordinate and get the y coordinate for that point. Those two coordinates will satisfy this equation. This is called the graph of this function. Now let's see what is the graph of a quadratic function. First of all and foremost important thing is graph of quadratic functions is a parabola. Now see, this is the graph of a parabola. This graph is a parabola. It starts at plus infinity, ends at plus infinity, and it achieves a minimum value during this move. Let's understand how to fix a parabola in 2 dimensions. Points to understand on parabolic graph, important points. First of all, you need to decide whether the parabola is upwards or downwards, means whether the parabola is opening up, that is starting from plus infinity going to plus infinity, or opening downwards, that is starting from minus infinity going to minus infinity. Vertex of parabola, line of symmetry, and position of x-axis and y-axis with respect to the parabola. Let's see. Here you see this is the graph of a parabola. Here if the parabola opens upwards, means plus infinity to plus infinity, it is called upwards parabola, and if the mouth is opening downwards, that it is starting from minus infinity going to minus infinity, it is called downwards parabola. The second is vertex of parabola. This point which is the minimum or the maximum value on the parabola, is called the vertex of the parabola. Next is the line of symmetry. This line is called the line of symmetry because if you see the right hand side of the parabola, it is exactly the mirror image of the left hand side of the parabola about this line. Means if you consider this line as a mirror, this line cuts the graph into two parts, which is mirror image of each other. The next important thing is the positioning of the x-axis. Whether the x-axis is cutting the parabola at 2 points, touching the parabola at the vertex, or it is going below the parabola or above the parabola and not at all touching or intersecting the parabola. The next is positioning of y-axis. This y-axis is positioned where with respect to the vertex of the parabola. The most important things in this is upwards or downwards parabola, vertex of the parabola, and positioning of x-axis as far as the quadratic equations is concerned. Let's analyze when the parabola will be opening upwards or downwards. We have already discussed this expression in Sridharacharya formula, that this can be reduced to a times x plus b by 2a whole squared minus d by 4a square. When a is multiplied inside, it becomes a into x plus b by 2a whole square minus d by 4a. Let's analyze this expression. Here a is a constant number. It can be either positive or negative. X plus b by 2a whole square, this is a perfect square, so this quantity is always positive. D by 4a is a constant number, may be positive or negative. D is the discriminant and a is the leading coefficient. Depending on the value of d and a, this number is a constant number, positive or negative. Now let's see where this x plus b by 2a whole squared varies. As the limit x tends to minus infinity, this x goes to minus infinity. There is nothing in this expression which makes it indeterminate form. So when x goes to minus infinity, we are adding b by 2a constant number to minus infinity. It will still be minus infinity. After squaring, we will get plus infinity. When x goes to plus infinity, this whole quantity goes to plus infinity. Means this quantity x plus b by 2a whole square is always positive. This constant a makes this entire expression either positive or negative. If a is positive, this whole number is positive. If this a is negative, this whole number is negative. This minus sign is very important. See, if we have, for example, if you have 1 crore rupees and I multiply it with minus 1, and now you have how much? You are in debt of 1 crore rupees. So this negative sign is a very powerful sign. You can understand this by simple logic. If you have good friends, then you can soar to new highs, and if you have bad friends, then you can depreciate to new depths. So this sign is very important. This quantity always varies from plus infinity to plus infinity, but this sign will make it either go from plus infinity to plus infinity, and if it is negative, it will make it go from minus infinity to minus infinity. This is a constant number. As I have already told you, it may be positive or negative depending on the constants a, b and c. So if a is positive, then this parabola will go from plus infinity to plus infinity, means its mouth will be opening upwards. For example, y is equal to x square plus x plus 1. Here a is 1, but since it is positive, this entire quantity goes from plus infinity to plus infinity, and it attains a minimum value. Remember, when a is positive, parabola opens upward and it attains a minimum value at its vertex. If a is negative, then the parabola opens downward. This quantity is a positive quantity multiplied by a negative number minus 2 will make it vary from minus infinity to minus infinity. So here a is minus 2, that is a negative number. It varies from minus infinity to minus infinity, and it attains a maximum value during its path. So this maximum value is attained at the vertex of the parabola. So if a is negative, parabola opens downwards. This is the example of minus 2x square plus x plus 1. Now let's see what is the value of vertex of the parabola. For that, you have to understand and remember always that if a is positive, we get a minimum value, parabola opens upwards. If a is negative, then parabola opens downwards and we get a maximum value of the function. For calculating the vertex of the parabola, if we are taking an example of a positive, suppose this a is positive number, then this quantity varies from, as x varies from minus infinity to plus infinity, this varies from plus infinity to plus infinity, means this number will be minimum at some point. This is a constant number. So whatever is the minimum value of this expression will be the minimum value of whole expression. Suppose this attains a minimum value of 2 and this is minus 1. So 2 minus 1, 1 will be the minimum value. This is a constant number, it doesn't matter. Whenever this expression becomes minimum, that will be the minimum value. So this number is a strictly positive number. A minimum positive number is what? 0. So let's try to solve the value for the vertex of the parabola. This a into x plus b by 2a whole square is always greater than or equal to 0 because I have assumed that a is always positive. So a is positive in this case. So this is a positive number. We multiply it on the both sides. So since it is a positive number, then inequality remains same. If it is a negative number, then inequality will change and this expression will become less than or equal to. But since a is positive, we will say that this is a strictly positive number greater than or equal to 0. A is positive, so we can divide by a on both sides without affecting the inequality. So x plus b by 2a whole square is greater than or equal to 0. This expression is always greater than or equal to 0. So what is the minimum value? Minimum value is 0 itself. This is equal to 0. This is the minimum value of the function. So this is a square. We take root on both sides. Root 0 is 0. We get x plus b by 2a is equal to 0 or x is equal to minus b by 2a. For x is equal to minus b by 2a, this number becomes 0 and that is the minimum value of this function. This number is minimum when it is 0 and is attained at x is equal to minus b by 2a. So for minimum or maximum value of this expression, x should be equal to minus b by 2a. So we get the value of x coordinate of the vertex of the parabola. This is the x coordinate of the vertex of the parabola. Now for x is equal to minus b by 2a, what is the value of the function? We put this value in the value of function. So if we put x is equal to minus b by 2a, this minus b by 2a plus b by 2a gets cancelled, becomes 0. Y is equal to minus d by 4a. So for x is equal to minus b by 2a, that is the point where it attains the minimum or maximum value, y is minus d by 4a. Therefore, we say that vertex is minus b by 2a x coordinate minus d by 4a y coordinate. This is the value of the vertex of the parabola. You must remember vertex of the parabola is minus b by 2a and minus d by 4a. Here, let's analyze the graph of y is equal to 2x square minus 8x minus 3. What is the value of a? 2, b minus 8 and c minus 3. So we have noted down all these values. Next thing important for a quadratic equation is the discriminant of the quadratic equation. So we'll calculate the discriminant, that is b square minus 4ac, that is 64 plus 24 is equal to 88. Now what we can analyze from this? A is equal to 2 is a positive number, it means parabola opens upwards. First conclusion is parabola upwards for this quadratic. Now vertex x coordinate is minus b by 2a, that is minus of minus 8, 8 by 2 times 2, 4. 8 by 4 is equal to 2. X coordinate of the vertex is 2 and y coordinate of the vertex is minus d by 4a. D is 88 minus t by 4 times 2, that is 8, that is, on solving we get minus 11. The vertex of the parabola is thus 2 comma minus 11. If we plot the graph, the actual graph of this function is like this: 2y is equal to 2x square minus 8x minus 3. So we can easily verify from the graph that the minimum value of this function occurs at x is equal to 2 and the value is minus 11, which is the coordinate of the vertex 2 comma minus 11. Hence we have verified also that the vertex is minus b by 2a and minus t by 4a. Remember this quantity, this is very important for the analysis of quadratic functions. Now see, the third important aspect in analysis of quadratic graph is positioning of x-axis. Where to keep the x-axis, whether the x-axis cuts the graph, whether the x-axis touches the graph, or whether the x-axis is totally below or above the graph. This x-axis is a line where the value of y is what? 0. On the x-axis, if you take any point, the value of y is 0. Means the graph will cut the x-axis only when y is equal to 0, and y is equal to 0 is what? Ax square plus bx plus c is equal to 0. Now this becomes a quadratic equation, means the points which satisfy the equation ax square plus bx plus c equal to 0 will be the points where the graph cuts the x-axis. Thus the points on the graph where it cuts the x-axis are the roots of the equation ax square plus bx plus c equal to 0, or in another words we can say alpha or beta, which are the roots of the equation. Example, y is equal to x square minus 5x plus 6, which can be factorized as x minus 2 into x minus 3. On solving we will get x is equal to 2 and x is equal to 3. So if you plot this graph on the graph paper, we will get this graph. You see that this graph intersects the x-axis at 2 points. One is 2 comma 0 and another is 3 comma 0. The value of y is 0 and the corresponding values of y x will be the points where it cuts the x-axis. Means you equate the equation to 0 and get the results or the values of x. Those will be the points where it cuts the x-axis. So first conclusion is the graph will cut x-axis in real points if roots are real. If roots are real, then the graph will cut the x-axis at two distinct points alpha comma beta. If a is greater than 0, parabola opens upwards, and if d is positive, it cuts the x-axis at two distinct points. A is negative, parabola downwards. D positive, it means it cuts the x-axis at two distinct points. You are getting two real roots. Now let's see example. If you consider the graph y equal to x square minus 5x plus 6, here discriminant is what? Discriminant is b square 25 minus 6 times 4 24, 25 minus 24 1. Discriminant is 1, which is a positive number, means we will get two distinct roots. Therefore the graph will cut at two distinct points. Two distinct roots means two distinct points of intersection with the x-axis. A is positive, parabola opens upwards, means A is positive, parabola upwards. D is positive, it cuts the x-axis at two distinct points. Another example, if this graph, if you multiply this entire equation by a minus sign, you will get y equal to minus x square plus 5x minus 6. Again d is 1, but a is equal to minus 1. So parabola opening downwards, but still intersecting the graph x-axis at two distinct points, which are the roots of the equation 2 and 3. Now the next conclusion, if d is equal to 0, how many roots you will get? You will get only one root. So the value of x for which y will be 0 will be 1. One value of x for which y becomes 0. The graph will touch the x-axis at one point. You can say touch or cut, it doesn't matter. You will get only one value of x. The possibility of this parabola to intersect the x-axis at only one point is that when it touches the x-axis or the vertex of the parabola lies on the x-axis. So if A positive, parabola upwards, D equal to 0, only one root, that is parabola touches the x-axis. Vertex, and these are the roots of the equation. Alpha is equal to beta is equal to this x coordinate of the vertex, which is minus b by 2a. A less than 0, parabola downwards, it touches the x-axis. Value of point where it touches the x-axis is the roots of the equation, or minus b by 2a. Let's take example for this. If y is equal to x square minus 4x plus 4, the discriminant is 4 square 16 minus 4 times 4 16 minus 16 0, discriminant is 0. So this quadratic becomes 0 for x is equal to 2. If you put x is equal to 2, this quadratic will become 0. So this quadratic touches the x-axis at 2 and again goes up. If it is a negative, then parabola is opening downwards, but still it will touch the x-axis at one point only. So A positive upwards, A negative downwards, D equal to 0 touches the x-axis. Third conclusion, if the roots are imaginary, that is, you put the equation f(x) equal to 0, you solve and you don't get any real values of x for which y is 0, means there will be no value of x for which y is 0, hence the graph cannot touch or cut the x-axis. Means if x is d is less than 0, the parabola is either totally above the x-axis or totally below the x-axis. So if a is positive and d is negative, the parabola is totally above the x-axis. If d is negative and a is negative, the parabola is totally below the x-axis. Now let's discuss an example. If we consider the equation y is equal to x square minus 4x plus 5, here value of a is 1, which is positive, discriminant 16 minus 20 minus 4, which is negative. It means if a is positive, well, parabola opens upwards. Discriminant is negative, means there is no real root, that is, the graph never cuts or touches the x-axis. Let's see another example. Y is equal to minus x square plus 4x minus 5, a minus 1, d minus 4. The parabola opens downwards and no real roots, means it will not cut or touch the x-axis. Remember, if you observe, these two equations are almost the same. Only difference is that in this expression I have multiplied minus 1 to get this expression. Means this equation and this equation are exactly same except for multiplication with a minus sign. So you observe the difference in the graph. If a is positive, it opens upward. If the a is negative, opens downwards. Rest all entirely same, but the behavior of graph changes depending on the value of a. Now let's discuss another point regarding the graph. It is positioning of y-axis. This point is not so important when solving questions, but to position the graph of quadratic, this is important. What we use to position the x-axis is that any point on y-axis has x coordinate 0. Any point on y-axis has x coordinate 0. Means to get the value of y where the graph cuts the y-axis, we have to put x is equal to 0. So to get this point, we put x is equal to 0 in the given equation. So this becomes 0, bx becomes 0, we are left with c. Means 0 comma c will be the point where the graph cuts the y-axis. Now we have positioned the x-axis and the y-axis for the quadratic graph. Now let's conclude the entire analysis and remember the 6 possible graphs of quadratic. There are total 6 possible graphs of quadratic with respect to x-axis, and 3 of them are for a positive and 3 of them are a negative. Means 3 graphs parabola opening upwards, 3 graphs parabola opening downwards. If you remember all these 6 graphs, you will have no problem in solving questions on quadratic graphs. Let's first discuss A positive. If A is positive, parabola opens upwards. Now, if discriminant is positive, the parabola is opening upwards. Discriminant is positive means two real distinct roots. The graph cuts the x-axis at two distinct points. If d is 0, then parabola is still opening upwards, but it touches the x-axis at exactly one point. A is positive, parabola is still opening upwards, but discriminant is negative, means there will be no real roots, that is, it will not touch or cut the graph of x-axis. Means if you observe this, A is positive in all 3 cases, the parabola is opening upwards, but if D is negative, the graph is below, little below, and it cuts the x-axis at two distinct points. Now this, as D is reducing, the graph is shifting upwards. The more D goes closer to 0, the more graph shifts upwards and comes closer to touching the x-axis. When D is equal to 0, the graph touches the x-axis, and when the D reduces further, the graph shifts upward and it is above the x-axis. Now let's see the cases for A less than 0. A less than 0, and if D is greater than 0, the graph cuts the x-axis at two distinct points and parabola opening downwards. If D is equal to 0, A is less than 0, parabola downwards, touches the x-axis. If A is less than 0, D less than 0, graph is totally below the x-axis. Means if A is positive, these are the 3 possibilities of graphs, and if A is negative, these are the 3 possibilities of graphs. If you remember these 6 graphs, you will be able to solve any question on quadratic graphs. Now let's discuss some examples for clearing this concept. Let's analyze the graph of y is equal to 3x square plus 2x minus 5. Here a is equal to 3, b is equal to 2, c is equal to minus 5. First observation, a is 3, means it is a positive number, the parabola opens upwards. Discriminant, b square minus 4ac, b square is 4, minus 4 times 3 12 times 5 60, with a minus sign it becomes plus, so discriminant is 64. Discriminant is positive, means two distinct real roots. Let's go for the positioning of the, now we know that the parabola is opening upwards and it will cut the x-axis at two distinct points. Now let's see where will this vertex lie. The vertex is, x coordinate is minus b by 2a, which is minus 2 by 6, which is minus 1 by 3, or I have converted it into decimal because this program is giving the coordinates value in decimals. So just to give you a idea that we are getting the exact result, I have converted into decimal. Minus 1 by 3 is minus 0.33333. Y coordinate of the vertex is minus d by 4a, which is minus 64 by 12. D is 64, minus 64 by 4 times 3, that is 12, which is minus 16 by 3 or minus 5.33333. So the vertex is minus 1 by 3 comma minus 16 by 3 or this number. Now the next important thing to position in this graph is the x-axis, where the graph cuts the x-axis. Here discriminant is positive, means it will cut the x-axis at two distinct points. The points will be the roots of the equation 3x square plus 2x minus 5 equal to 0. You convert this expression into an equation equal to 0 and then solve it. You will get x is equal to 1 and minus 5 by 3, means one point will be x is equal to 1 comma 0, where the graph cuts the x-axis, and the another will be minus 5 by 3 comma 0. The 2 points are 1 comma 0 and minus 5 by 3 comma 0. To get the position where the graph cuts the y-axis, we put x is equal to 0. We put x equal to 0 in this, we get y is equal to minus 5. So finally, we have positioned the graph of this quadratic as a parabola opening upwards, vertex at minus 1 by 3 comma minus 16 by 3. Points where it cuts the x-axis is 1 comma 0 and minus 5 by 3 comma 0, and point where it cuts the y-axis is 0 comma minus 5. Let's discuss one more example. Here let's discuss one more example. Y is equal to minus 2x square plus 2x minus 3. A is minus 2, B is 2 and C is minus 3. So since A is negative, the parabola opens downwards. First important thing, discriminant is b square minus 4ac, which is 4 minus 24 minus 20. B square is 4 minus 3 times 2, 6 times 4, 24. 4 minus 24 minus 20, which is a negative number, so no real roots. It means the graph is either completely below or completely above the x-axis. In this case, parabola opening downwards, so it will be completely below the x-axis. Coordinates of the vertex, Vx is minus b by 2a, which is 1 by 2. Vy, that is y coordinate of vertex, is minus 5 by 2 minus t by 4a. Now vertex is 1 by 2 comma minus 5 by 2, or 0.5 comma minus 2.5. X equal to 0 means y is equal to minus 3. The point where graph cuts the y-axis is 0 minus 3. So we have positioned the graph of this quadratic on graph. Let's discuss one example where we'll be able to analyze the graph conceptually. In this question, we are given that if this is the graph of the quadratic function, then we have to predict the sign of b. If this is the graph of quadratic, what will be the sign of b? The equation is general equation, ay is equal to ax square plus bx plus c. So we observe that the parabola is opening downwards, means what? A is negative. The graph cuts the x-axis at two distinct points. Interpretation, discriminant is positive. So let's see, parabola downwards, A negative, two real roots, discriminant positive. And since the graph cuts the y-axis below the x-axis, means y coordinate of this point will be negative, or c is less than 0. We have predicted the sign of a is negative, c is negative. Only thing remaining to predict this expression is b. For b, we observe that the x coordinate of the vertex is negative, that is on the left hand side of the y-axis. So this is negative, hence the x coordinate minus b by 2a will be less than 0. There is a minus sign. What we do, we multiply this entire expression with minus 1. Since we are multiplying it by a negative number, the inequality sign will be reversed. Instead of less than 0, now it will be greater than 0. So b by 2a is greater than 0. Now we have to multiply it by 2a to get the sign of b. A is negative, 2a will be negative. When we will be multiplying this entire expression by 2a, we are multiplying by a negative number, hence the sign of inequality will again change and it will become b is less than 0. So in this graph, the quadratic expression will have a negative, c negative and b negative. All the coefficients will be negative. Thank you very much for watching. Please do subscribe to my channel YLC, that is your learning curve. And as I always say, remember, practice makes a man perfect and there is no substitute for hard work. Thank you very much.